can do. It says if you have a voltage source, let's give it a value of Vs, for example, with the resistor here, let's give it the value R sub I for input, and this is attached to a circuit. The rest of the circuit, I could care less what's going on there. I can, if I want to, take that circuit and take this source and that one and replace them with a resistor in parallel to that, and the value of that resistor will stay the same as this one. That doesn't change. But instead of a voltage source, I can replace it with the current source. And the value of the current source will be this one divided by that. Ohm's law. I equals V over R. These two circuits will be equal. Or vice versa. If I have a current source, I sub S, in parallel with the resistor, R sub I, and is attached to a circuit here, I could take this current source, change it to a voltage source in series with the same resistor. So the resistor doesn't change. What's going to change is that current source become a voltage, where V equals what? Ohm's law. I times R. So the value of this source is going to be I sub S times R sub I. That's really what source transformation is. You're going to see how this actually makes the problem sometimes 10 times easier. I'll start with an easy example, then I'll make it worse. So here's an example. I have a 9 milliamp current source in parallel with 5 kilo ohm. On the top here I have 4.7K, another resistor of 3K, and a voltage source of 3 volts. And the question, what is I here? Now, if that was given to me in a problem, I can do mesh or node. It's really one equation by one unknown, because I can combine these guys together. It doesn't affect I. I know the voltage here. That's the only voltage I don't know. So if I do node analysis, there's one node. If I do mesh analysis, I know what this current is, right? So that's the only current I don't know. So it's not a big deal with this one, but I'm going to show you how source transformation works. This one says if you have a current source in parallel with the resistor, and that's what we have here, I can change it to a voltage source in series with that resistor. So let me do that. I'm going to change that to a voltage source. I'll come back and calculate the value. The resistor value does not change. There's the 5K. 4.7K. 3K. And what's the value of that voltage source?
45.
It's 9 milli times V equals I times R, right? So the voltage of this, the value of this source is going to be 9 milliamp times 5K. The millis and Ks will cancel. You end up with what? 45 volts. And again, I can redraw the circuit by saying, oh, I got a 45 volt source here. I got one resistor on the top. I'm going to combine them into one. When I add them, 7 and 5, 12.7 is it? So now I can do a KVL or mesh equation right here. This is plus to minus. We know that current is I. There's only one current going through that. So negative 45 plus 12.7 K times I plus 3 is equal to 0. 12.7 K times I equals what? Is that a 42? What's I equal to? 42 divided by 12.7 K. .3 milliamp. This wasn't really a big circuit, so you could have done it mesh, nodal, or source transformation. It will not change anything. But let me give you